Welcome to Ask and Learn.
Hi all, Alex B here with another question on electric power from chapter 25 of Giancali's Physics for Scientists and Engineers. So this question tells us that we have two 1.5 volt D cell batteries and a flashlight, and it's going to draw a current of 380 milliamps. Now the first part of the question, part A, asks us to calculate the resistance and power of this bulb. So to get the resistance, we're going to use our Ohm's law equation of V equals IR, and we're going to rearrange it to find that R is equal to V divided by I. We're going to plug in. We have two 1.5 volt batteries connected in series, so in total we have 3 volts, and it's drawing 380 milliamps, which I'm going to write as 0.38 amps. If we plug these two in, we should find that we have a resistance of about 7.9 ohms. For the power, we're going to use our equation for electric power of P equals I times V, where again I is 0.38 amps, and V is again 3.0 volts. And we're going to calculate that it has a power of about 1.1 watts. So not super powerful. But part B asks us, what happens if we increase the voltage by putting in 4 D-cell batteries instead? Well, V is going to go to 2V. And you might think by looking at this equation that that means power is going to double. But we have to be careful, because increasing the voltage is also going to increase the current. So we need to use our equation of P equals V squared over R, which is going to assume that the resistance stays the same even if the current changes. And we're going to neglect any heating effects, so we're going to indeed assume that the resistance is going to stay the same. This means doubling the voltage actually leads to a quadrupling of the power. Now, as to why this is a bad idea, presumably 4 times the power is over the bulb's rating, and it will probably burn out and maybe even explode.